Using science to debunk the myths that support prohibition of novel nicotine products, vaping products, pouches, and so on. Can we start the slides, please? There we go. So what we're going to do today, I will first introduce the panelists, the three esteemed scientists sitting on my right. I'm going to kind of introduce the session, why are we here, what is this all about, and then we're going to get into some myth busting. And I'll explain this in a little while, what we're going to do. And then we want to do some busting of your own myths, the things that you hear that maybe we haven't covered in our presentation. So that's just to set your brains whirring. If you think of any myths that we haven't covered, then please do bring them up in the end in the Q&A, and we'll do our best to bust those for you as well, and then we'll wrap up. So just a quick introduction. I'm Ian Fear, and I've been working in the field of tobacco harm reduction as a scientist for 18 years now. I work as a science and regulation consultant to tobacco companies, nicotine companies, drug companies, CROs and advocacy groups. I'm also a non-executive director and board member with Advanced Inhalation Rituals, or AIR. I'm a scientific advisory board with Qnovia, who are a nicotine replacement therapy startup. And one thing just to say, any views I express are my own and don't necessarily represent the views of the companies that I associate with. Ariel, who is actually on the third leg of an Ironman triathlon this morning, so she's just about to start the run. And I do admire your energy. So Ariel is a behavioral scientist and specializing in tobacco harm reduction. She's a senior scientist at Pinney Associates, and they support dual labs in their science and regulatory efforts through behavioral work, statistics, and publishing. She's also a scientific consultant to this conference, and very prolific, more than 70 scientific publications, does a lot of critiquing of published research, which is very important and really kind of meshes in with what we're doing today in terms of critiquing the myths that are perpetuating. And she also communicates science more broadly on social media, which is, again, hugely important to get the messages to larger audiences, and particularly the users of the products that we're all supportive of. Libby is a scientific substantiation and engagement lead at Imperial Brands. She leads teams specializing in alternatives to animal testing, clinical and behavioral science, and scientific surveillance. In her career within the industry, she's undertaken quantitative toxicological risk assessment, scientific surveillance, and the leadership of non-clinical work streams supporting market entry for novel nicotine products. And allied again with the theme of this session, the central theme of her work, which is the importance of data-driven, evidence-based communication of complex science. And the evidence base, I think, is the important bit there. And last, but certainly by no means least, Konstantinos Varsalinos, who I'm sure is familiar to all of you, is a physician and public health expert and research associate at the University of Patras and the University of West Attica. He's been conducting laboratory, clinical, and epidemiological studies on smoking and harm reduction since 2011. Very prolific as well, more than 120 published studies and articles in peer-reviewed scientific journals, and presented at more than 80 international conferences. And is a founder and acting vice president of the International Association on Smoking Control and Harm Reduction. So why are we here, and what is this all about? Well, it's all about prohibition, and this is just one example of the World Health Organization congratulating India for banning electronic cigarettes. And India is not just an isolated example. We see this all over the world. These are just some things I pulled off the internet in Cambodia and Brazil and Mexico and the Middle East. everywhere it seems that there are either partial, i.e. restrictions on things like flavors, or complete bans, restrictions on the selling of a category of product like a vaping product or a nicotine pouch. And this is increasing. It's not showing any signs of slowing down. It seems like every day we hear about a new country that's thinking of implementing a ban of some sort or other. And this map just shows kind of a global picture of what those bans look like. So the blue on this slide, the countries are those which regulate novel nicotine products, and the red countries are those which have completely banned some of them. And the blue is a little bit misleading, for example, with Australia, because while vaping products are actually regulated in Australia, they're regulated in such a way that it's almost a de facto ban on vaping products, because you can only get them on prescription and nobody's doing so. And we're also aware of the ensuing effects of that on things like illicit trade and criminal activity. So what is supporting prohibition? Well, if you ask those that support prohibition, they will say, well, it's the science. The science is leading to prohibition. And I think what we're going to talk about today is how a lot of that science is flawed. So, for example, here we have, what's actually in your vape, and saying that vapes contain harmful metals and formaldehyde that you find in floor cleaner, and acrolein that you find to kill insects. And that is kind of partially true, but I'm sure that Libby will tell you that they're at such low levels that they're not of toxicological concern. But people are using that to say, you've got to ban these things because they contain dangerous chemicals. Other examples, vaping is just as bad for your heart as smoking cigarettes, or vaping causes irreversible lung disease, or vaping is a gateway to cigarette smoking. It's not true, but scientists have published papers supporting this type of information, and that then gets carried into governments, into regulation, and we see prohibition. And of course, prohibition is perilous. These are just 5 examples that I thought of when I was writing these slides of, what impact prohibition, what negative impact it can actually have. Reducing access to life-saving products for adult smokers, something which, if they switch exclusively to it, is going to reduce the impact on their health and the likelihood of them dying early. Increased smoking reinitiation or relapse back to cigarette smoking. If a smoker has started vaping and the vaping products get banned, one of their only options to continue nicotine consumption is to go back to smoking cigarettes, and of course that's not great for them. It punishes consumers in much the same way as manufacturers can be punished, consumers can be punished. In some countries, the regulations of prohibition is such that as a consumer, as a user of those products, you can be fined or even imprisoned just for using a vaping product or a nicotine pouch. It fuels an illicit trade, of course. Wherever something is banned, the illicit trade fills that gap quite quickly and easily. And we've seen that, as I said earlier, to a large degree in Australia, but also in many other countries across the world as well. And we see increasing harms due to consumer innovation. If flavored e-liquids are banned, consumers will buy an unflavored e-liquid and squirt in some lemon food flavoring they bought from the supermarket to give them a fruit-flavored e-liquid. And of course, there is a toxicological concern of doing that. So there are perils to prohibition. The environment may be changing, and one example is in the United States, where historically the regulator, the Food and Drug Administration, has been reluctant to approve or to authorize anything other than a tobacco-flavored vaping or nicotine pouch product. But we have recently seen menthol vapes have been approved, a multitude of flavors of Zyn nicotine pouches have been approved, and last month FDA authorized for the first time ever a blueberry and a mango-flavored glass vaping product. So in some countries, we are seeing positive change, positive in terms of enhancing public health and enhancing the options that smokers have to switch to. But this is not global. And this is just one example of the World Health Organization pushing not only for flavor restrictions, but also for outright bans of certain types of novel nicotine products. So what we're going to do today is look at scientific information. And we're looking at scientific information in certain kind of areas or themes. And the reason for this is because the calls for either partial, i.e. flavor bans, or complete prohibition, just completely banning vapes or pouches or heated tobacco, these are often, in inverted commas, evidence-based. And the scope of these calls is not finite. They're focused on discrete themes, and we see these themes again and again and again, just popping up in different countries around the world as they look at banning vaping products, nicotine pouches. And what we're going to do, each of us, is present factual counter-evidence in 2 themes. So we're going to discuss 8 themes in total. And I bolded, underlined, and italicized factual, because what we really wanted this to be is almost in a kind of an opinion-free zone. We want to provide you with scientific evidence, and each of the presenters will actually give you links to publications and citations that you can use. And we want this to support your advocacy. So for those of you who are speaking around the world with government ministers, health ministers, finance ministers, etc., about why they shouldn't ban novel nicotine products, when they state the reasons why, and typically it will fit into one of the themes we discuss, you will give them some evidence to counteract that. And that's really what we want to do, is to support your advocacy in the end markets that you work in. These are the 8 themes. As I say, each of us will look at 2 of them. I won't dwell on this, leave it on the screen for too long, because you're going to see this on everybody's slides anyway. But these are the 8 common myths that we often see that are being used to support prohibition, and we're going to try and dispel each of these. And then, as I say, we're going to open it up to the audience. If there's any myths that aren't on this list that you want us to try and myth bust as well, we'll be more than happy to do so. I'm just going to take a drink before I start with theme 1. So theme 1, and I hear this quite commonly, is that novel nicotine products don't help smokers quit. They're not helpful in smoking cessation. And it's probably the simplest myth to dispel, and you can do this myth busting in a single word, beginning with C. I'll let you think about what it might be. But it's Cochrane. That's the only word you need to know when you're busting the myth that novel products don't help smokers quit smoking. For those of you that don't know, and I'm pretty sure that most of you do, the Cochrane Group is a global independent non-profit network of researchers, patients, carers, and they work together to produce trusted, high-quality health information that improves health and healthcare worldwide. And basically what they do is they take a hypothesis, an idea, and in this example, what they're looking at is, do e-cigarettes help people stop smoking? And they dig around on the internet and in databases, and they find all the evidence that might help them address that particular topic. They assimilate it, and they provide an outcome. Do e-cigarettes help smokers stop smoking? And this is their latest publication from last year, Nicholas Linson and colleagues in 2025. This was an extremely rigorous, and I can't highlight this enough, independent analysis. And this analysis is done to a set of rigorous methodologies. And basically, this means that the evidence coming from this analysis is pretty much incontrovertible. If Cochrane say, this is this, then it is that. You really can't argue against it because they've looked at all the information possibly available to answer that question. And when looking at e-cigarettes for smoking cessation, they examined 104 studies. That's quite a large number. 14 which had been published since their previous assessment in 2024, and 61 of these were randomized controlled trials. And these are often thought of as the gold standard for assessing the efficacy. Certainly for pharmaceutical products, they're the gold standard. There is an argument that real-world evidence is just as strong or even stronger with respect to electronic cigarettes, which are a consumer good. And they analyzed data from 30,366 smokers. That's a huge number. And this is what they found. That nicotine-containing electronic cigarettes result in an increased quit rate compared to nicotine replacement therapy, or NRT. And that conclusion is supported by what they call high certainty evidence. It's not limited by bias or low quality of the studies which went up to form that conclusion. It's high certainty evidence. And the number there, the risk ratio 1.55, what that suggests is on average across all the studies that they looked at, that nicotine-containing e-cigarettes were 55% better than nicotine replacement therapy in helping smokers quit. And what they then said was, in absolute terms, this might translate to an additional 3 quitters per 100. And you might think, well, that's only 3 per 100, you know, it could be better. But when you translate that into the number of smokers within a given population who are trying to quit smoking, which is probably in the tens, hundreds of thousands, or even millions, then that, in absolute terms, is a huge number of people. And what they also said was data from non-randomized studies, so observational studies, were consistent with randomized controlled trial data. So the gold standard of randomized controlled trials, the non-randomized studies, basically showed the same thing. So I'm just going to very quickly talk about 2 of the papers that were in this Cochrane review, 2 of the most prominent ones in my view. The first one was by Peter Hayek's group in London, published in the New England Journal of Medicine, I think in 2018. And this group took 886 cigarette smokers, randomized them either to use electronic cigarettes or nicotine replacement therapy, and looked at smoking cessation, how many people were able to stop smoking. The e-cigarette they initially supplied was a tank system, and they gave them people a tobacco-flavored liquid, and the participants were then told to go and purchase your own liquids with whatever nicotine strength you want, whatever flavor you want, pretty much replicating what vapors will do in the real world. In the nicotine group, the participants chose from various forms of nicotine replacement therapy. Combinations were encouraged. And again, this pretty much mirrors what happens in the real world. Certainly in the UK with the stop smoking services, they get the participants to choose which product they think will work best for them. And this is what they found. I really just want you to focus on the top yellow line. This is the number of people who were abstinent, i.e. they were not cigarette smoking a year after they had started in the study at 52 weeks. And for e-cigarettes, 18% of those people who were randomized to use electronic cigarettes were abstinent from cigarette smoking. And this compared to only 9.9% for the nicotine replacement therapy group. That's almost a doubling. You know, what you can take away from that is e-cigarettes are almost twice as good as nicotine replacement therapy in helping people stop smoking. And the other thing I just want to point out is the bottom line that starts with carbon monoxide. And basically what this is showing is the number of people who didn't manage to quit smoking but reduced their cigarette consumption by at least half. And again, in the e-cigarette group, it was 12.8% of people. In the NRT group, it was 7.4%. Again, almost a doubling of the number of people who were enabled to reduce their cigarette consumption significantly. A very similar paper also published in the New England Journal a little more recently in the last year or two by Reto Oya. Slightly larger number of subjects, 1,246, but similar to the Hayek paper, they were randomized to either cigarettes or control. e-cigarettes or control. The e-cigarette was a refillable tank, again, with various different flavors or nicotine strengths available. The control group received what they would typically receive if they've been asked to go seek professional smoking cessation support, so cognitive behavioral therapy, nicotine replacement therapy, etc. And again, the key findings, the validated abstinence, and validated means that they had their breath carbon monoxide levels checked, but the continuous abstinence in the e-cigarette group was 28.9%, and it was only 16.3% in the control group. And again, that's almost a doubling of the efficacy. In the percentage who abstained from smoking in the 7 days before the 6-month visit, i.e. they didn't have continuous abstinence, but they were abstinence in the week before the 6-month visit, this was 59.6% in the e-cigarette group and 38.5% in the control group. Again, almost a doubling. And I've included the statement at the bottom because when I hear those in tobacco control talk about this paper, they say, yeah, but what you've done is just replaced one addiction with another, and people aren't completely nicotine abstinent. They may have stopped smoking, but they're not completely nicotine abstinent. And so the third conclusion there was that the percentage who abstained from any nicotine use was 20.1% in the e-cigarette group and 33.7% in the control group. And the critics then say that this is just indicating that you've just swapped one addiction for another. But for me, that's a flawed argument, because I'd rather somebody be addicted to something that doesn't contain humongous amounts of formaldehyde and benzene and acrolein and lots of other nasty chemicals that they get from their cigarette smoking, rather than actually remaining smoking. So this myth that novel nicotine products don't help smokers quit is not supported by the evidence, in my view. Very simple to debunk. Just use the Cochrane analysis. It's incontrovertible. This evidence supporting that vaping products actually do help smokers quit smoking comes from individual studies, syntheses such as the Cochrane review, but other systematic reviews have been published. And they'd all demonstrate a clear effectiveness of e-cigarettes in supporting smoking cessation, which is greater than that of standard care, including nicotine replacement therapy. And one thing I just want to point out at this stage, I've just talked about vaping products. I haven't really talked about nicotine pouches. Cochrane are looking into whether nicotine pouches can also help smokers stop smoking. And I can only assume we'll see those findings from those analyses in the next year or so. So theme 2, and again, I often hear this, we already have things to help people stop smoking. Nicotine replacement therapy or other medications that are proven to help people stop smoking. So what I've done on this slide, on the bottom are various ways, various methods people can use to stop smoking, unsupported, i.e. cold turkey, nicotine replacement therapy, gum, lozenge, patch, inhaler, mouth spray, and then the pharmacotherapies, bupropion, varenicline, cytosine. And on the right is just the percentage. And the way of looking at these bars is to say for each of those methods of quitting smoking, if you were to ask 100 cigarette smokers to use that method, how many would actually be successful in quitting smoking? Unsupported, cold turkey is very difficult. Low single-digit percentage of people actually achieve unsupported smoking cessation. We see values somewhere between 13 and 19 for different forms of nicotine replacement therapy. And for the pharmacotherapies, we see a little more success, somewhere between 20 and 22%. What I haven't included on this slide, just for complete clarity, we do know, of course, that combination therapy is more effective than monotherapy when it comes to smoking cessation. So the use, say, of a slow-acting form of nicotine intake like a patch with a faster-acting form like the inhaler does produce greater efficacy, greater support in helping people stop smoking. But it's really incremental. It doesn't make these bars that much bigger. And what I thought would be interesting to do is to compare these medicines, which people are prescribed or they buy over the counter, with other things that they might be prescribed. And you see these medications, they're just not very good at all. If you compare them with statins that reduce people's cholesterol, amoxicillin, which is used to treat lung infections in smokers, or lisinopril, which is used to control people's blood pressure, then you can actually see how normal drugs, typical drugs, other drugs actually help people compared to the percentages for the nicotine replacement therapy and pharmacotherapies. But what I also thought would be useful would be to add one other bar, and it's this one, 51.2%. So if you took 100 cigarette smokers, gave them this product, and said, use this to try and quit smoking, then half of them, over half of them, a year later would have completely stopped smoking cigarettes. And that product, any guesses what that product might be? No? I'll tell you. It's Juul. The electronic cigarette Juul helps more than a half of smokers stop smoking. And this data point comes from a survey which recruited a massive number of Juul users at their point of first purchase. I think it was well over 20,000, if I'm correct. Is that right?
Yeah, it was about 20,000.
Yeah, about 20,000 people recruited at their point of first purchase of Juul, and they were cigarette smokers at that time. A year later, 10,000 of them had stopped smoking. That's just incredible. And you just look at that comparison between Juul and the other therapies, and it's night and day. And this concurs very nicely, of course, with the Cochrane review finding and the randomized controlled trial findings as well. But it's real-world evidence. It's survey data of people using Juul in the real world, so it's extremely valuable. I won't dwell on this slide. All of these slides will be available, of course, afterwards, or you can watch the video online. And as I say, we wanted to give you some citations and the actual links to the evidence. So these are my links to the evidence, and the other presenters as well will do similarly. And I just wanted to end with a couple of quotes from eminent tobacco control but non-prohibitionist scientists, one of which is Nancy Rigotti at the Massachusetts General Hospital, well known for her clinical research in smoking cessation. And Nancy said recently, it is now time for the medical community to acknowledge this progress, i.e. the progress of novel nicotine products helping smokers to stop smoking, and to add e-cigarettes to the smoking cessation toolkit. And Neil Benovitz from the University of California, San Francisco, also recently said the adoption of electronic cigarettes rather than cigarette smoking might therefore result in an overall benefit from public health. And that's it from me. I'm now going to hand over to Ariane.
Okay, thank you. So as Ian mentioned, I work for Pinney Associates, consult for Juul, advise to this conference, but my content today is also going to focus on my extensive work reviewing the literature and identifying common flaws. I am going to try to keep each of my two themes to 5 minutes, so I'm going to talk fast. Apologies in advance, but if you stay with me, I have a QR code at the end where you can download like a more detailed version with copious amounts of references, because I didn't want to clutter up my slides. So youth epidemic. Here's some examples of the youth epidemic claim. All of these examples, by the way, are taken from the Twitter account that keeps track of THR-related community notes. If you're not on Twitter, X, community notes are for like just normal users to call out misinformation that they see. Tweets from the WHO related to tobacco have a high chance of getting hit with a community note because they're very misleading. So youth epidemic, vaping is the next opioid crisis. Aggressive marketing by the tobacco industry is leading to a new wave of nicotine addiction. Vaping among children has increased 5-fold since 2019. And I see in a lot of academic articles, they end with the 2019 data point, which you'll see the reason for in a moment. That's because youth vaping peaked in 2019 in the US. A lot of these articles end, like I see still in 2026, I see scientific articles saying youth vaping increased exponentially, reaching 20% in 2019. It's like, oh yeah, what happened in the 5 years since then? Overall use of any nicotine product by youth has dropped by about 2/3. Most of that was from e-cigarettes, so that e-cigarettes, any use of e-cigarettes in the past month has fallen by over 70% since the peak in 2019. Don't have time right now to get into differences across countries, but I'm happy to talk about that later. When we go back to what used to occur, monitoring the future is probably the longest running US survey of youth tobacco use that I'm aware of, going back to 1975. You can see that the rates were pretty stubborn at 20 to 30% right up until around the Master Settlement Agreement in just before 2000. Since then, smoking has declined among the three lines here are 8th, 10th, and 12th graders in monitoring the future. And they've declined to historic lows. So now reaching about 1.6% in 2024. And when you look at, this was any use of cigarettes in the past month, so that encompasses somebody who tried it once to somebody who uses daily. Smoking 10 cigarettes per day was less than 0.5% of all grades. Critics will point to the rise in vaping and present that in isolation, or else if they acknowledge the decline in smoking, they'll paint it as the decline in smoking was already happening because of strong tobacco control measures, but now e-cigarettes are threatening that, or nicotine pouch uptake is threatening that progress. But is this a valid reason to claim epidemic? I have to credit my boss, Joe Gitchell, for this next point, because he goes back to Healthy People 2020, which was a CDC initiative that tracks performances of indicators for various health behaviors and sets goals for what public health can accomplish in the next 10 years. I'm using the semi-kooky phrase residue from another timeline, which is like kooky theories about shifting timelines, but it's a really valuable analogy for this because this is proof in 2020 Healthy People. It's proof of what tobacco control thought was the ideal achievement. And that was going from a baseline of 19.5% of youth who smoked cigarettes in the past month to 16. That was the ideal achievement. What happened in right before 2020 in the target, YRBS 19, which is what this data, these targets are based on, was 6% for cigarettes. There is a case to be made that it did total use of any nicotine or tobacco product increased in 2019, but that again was because of the spike, the transient spike in e-cigarette use. And since it's come down to 17.9% in 2023, the most recent data point. Even more reinforcing of this point is that the 2020 targets were set by retaining the 2010 targets. So between 2000, when the 2010 targets were set, and in those subsequent 10 years, they were not able to achieve the target of 16%. And then all of a sudden, after vaping, we're now down to 3.5% or even lower since that was 2023. More recent data has not come out yet, but I expect that to be even lower. Next is that past month use is the measure often thrown around, but that can encompass anything from I tried a friend's vape at a party over the weekend to vaping daily. One measure that I like to look at in NYTS, and this is shown in the table, if you look at the ratio of past month use in NYTS to lifetime use, that kind of captures how many kids experimented with smoking who continued to use to continue to vape at the time of the survey versus they tried it a couple times and then it didn't take and they stopped doing it. That's about 50% or less in NYTS. And then when you look longitudinally, there's not a lot of research out there, so I did a paper on this over the past year. I looked in PATH data, which follows youth over time, and I got the ones that initiated at or around the 2019 peak in youth vaping, and I followed up 2 years later, what were they doing afterwards? 60% of them either completely stopped vaping or reduced their level of use. There was a small portion that either escalated or was kind of persistent, frequent use, and there's a case to be made that we should do something about those kids, but to paint this as a youth epidemic is misleading. Finally, Scandinavia has shown great success in shifting the population consumption from combustible to non-combustible. So here's an example in Norway where the overall use of any product is stable or slightly decreasing, but underlying that is a drastic shift of snus uptake offset by cigarette declines. And we're seeing very similar patterns in the US now. So on the right-hand side is data from PATH. The bottom figure shows use of either product or any nicotine product, and that's approximately stable or declining. But underneath that is drastic declines in smoking and increases in vaping. So I think there's a case to be made for this is harm reduction at the population level because consumption patterns are shifting. Okay, there's my QR code I promised. If you can't get your phone up in time, feel free to talk to me afterwards, but I've written up all these and provided footnotes and references. So overall, youth epidemic, I think, is misleading because overall tobacco use has declined. Population consumption is shifting to a less harmful mode. And I think if we look back to Healthy People 2020 targets, which is this residue from that other timeline is increasingly hard to find. It's no longer on the CDC's website, so I've downloaded a copy and linked to that in the fact sheet as well, just to have some proof that back in 2010, these kind of declines were unprecedented and unimaginable. Next, gateway to smoking or addiction. More examples of the gateway claim that got hit with community notes on Twitter. One of them, I think with these meta-analyses of gateway studies, the common pooled estimate is now an odds ratio of 3, so this is kind of misphrased as young people who vape are 3 times as likely to take up smoking. But the evidence that this is based on is survey data, asking youth what substances they use and finding that youth who vape are also more likely to smoke. But this misinterprets correlation as cause and effect. The alternative explanation is that risky behaviors cluster together. That's what my figure there shows. It's another survey showing pretty tight clusters of different risky behaviors. And so maybe there's pre-existing characteristics like mental health symptoms that drive some people to self-medicate, or risk-seeking personality, or maybe your family smokes, friends smoke. All of these things are pre-existing factors that can explain why youth both smoke and vape. Evidence for the common liability is that this bar chart is from an older paper of mine showing the unadjusted association in red. So if you just correlate smoking and vaping, it's a quite strong and positive association. But if you control for more of these common liability factors, the association attenuates quite a bit to what's in the orange. And then if you use a more sophisticated methodology, in some cases it's no longer significant. So in these, I couldn't rule out a possible causal effect on experimentation. It may or may not be causal, but I was able to rule out an effect on current smoking. So maybe a transient experimentation, I can't rule that out, but as far as continuing to smoke, that is completely explained by shared risk factors. Mutual associations too. So if the gateway association is you vape first and that causes you to smoke, that's the theory. But the reverse finding is also has equal evidence. So if you smoke first, you're more likely to vape. This other paper in my quoted tweet here looked at cannabis, alcohol, and then other tobacco products as well, and essentially finds that everything's a gateway to everything else. And my comment was, if everything's a gateway, then nothing is. There's nothing unique particularly about vaping leading to smoking. It's just part of the shared cluster of risk factors and risk behaviors. Next, gateway is contradicted by population level trends. If you think about the predictions of the gateway, it's that if more youth are smoking in the population, you would expect to see more cigarette smoking than you would otherwise expect to see. So there's this figure shows a simulation model that I did where I replicated the pre-e-cigarette trends from like 2000 to 2010. I then projected them forward in the blue with no changes. The yellow line there is the actual data, and gateway is red. So you can see that the gateway scenario massively overpredicts the actual smoking prevalence among youth. Even the no effect situation in blue overpredicts, and what this means is that gateway, you need a strong a strong diversion effect to explain the observed declines in smoking. It doesn't prove diversion with this level of data, but what it can show is that gateway is inconsistent with observed data. Natural experiment studies, so in the absence of being able to experiment and like randomly assign e-cigarette use, which is unethical, of course, natural experiment studies where you have, for example, some US states that have a policy restricting e-cigarettes or tax increases versus comparison states that don't, that provides like the strongest second tier of evidence. And this consistently shows that that there's a substitution effect between e-cigarettes and cigarettes. So if you have a policy that restricts one, you see increases in the other. There was also a systematic review by Cochrane authors reviewing these types of studies at the population level and finding an inverse association. The evidence wasn't strong just because there's still bias and inconsistency in these studies, but it does lean towards an inverse association rather than both things increase together as gateway would predict. Finally, some of the language more recently with the massive declines in smoking, it's no longer really that credible or defensible to say vaping is a gateway to smoking, but what they are saying now in some cases is, well, it's a gateway to addiction because kids can still be addicted to vaping in and of itself. But that's also declining at the population level. This is a great study by Sarah Jackson, again, analyzing NYTS to look at symptoms of dependence, and that tracked with prevalence. So you see a slight peak in 2019, and the dependence burden at the population is now also much lower than it used to be. And that's because of declining prevalence of all products, as well as the lower dependence potential of e-cigarettes. And then there's my QR code for that claim. So essentially, gateways misinterpreted evidence. It's interpreted as causality when it's really just a general propensity for experimentation or substance use. And when you look at more high-quality evidence, such as natural experiment studies, it shows a substitution or inverse association. All right, that's it for me. Happy to pass it over.
Thank you, Aria. We're now going to move on to Libby.
Sorry. Yes, it's time. Thank you. Thanks. Lovely. Thank you very much, Ian. And good afternoon, everyone. So I've got two more myths. We'll cover them after the disclosure. So I'm an employee of Imperial Brands, which is a manufacturer of tobacco and next-generation nicotine products. So the first myth that I'll be covering today is that vape aerosol contains toxic chemicals and metals, which is the kind of headline that we've often seen in the media. But these statements are also made by regulatory and public health authorities. And I think these types of statements really do form the basis of this myth, because it does appear, when you read through them, that just the presence of these chemicals could confer a harm to the consumer. So there's 3 examples shown there. I won't read them out. But the one I wanted to highlight was the statement by the European Commission that was made in the recent evaluation report a couple of months ago. And they make that statement. And of all the research and all of the studies that exist in this particular space, they only used one study in support of that statement, which was a hazard screen. Now, that is significant because a hazard screen or hazard identification study by itself is not sufficient to infer risk to the consumer. So toxicological relevance is calculated based on the dose response. So at what level does that chemical, where's the association with adverse effects? And then in comparison, what's the exposure to the consumer? So all three of those will be used to inform the risk characterization, which will be used to inform decision making, and hazard identification alone does not inform risk. So what is in the vape aerosol? I'm sure, as everybody here will be aware, vape aerosol is predominantly PG, VG, and water, with a minor contribution from flavourings. So generally speaking, from robust, well-conducted studies, low levels of carbonyls and low or trace levels of metals have been reported. There is a little bit of variation depending on device type and some other factors, but we will look into that now. So firstly, the impact of flavours. So studies indicate that flavour constituents may affect carbonyl emissions, but the overall impact is low. And the reason that the overall impact is low is because flavours only make up a very low proportion of the overall e-liquid. So it's usually around 3% or less. So I would say that any studies which show large variations in carbonyls which are attributed to flavours should be a flag to the reader to go back to the methods and have a look and see how that data has been generated. So whilst the flavours make a minor contribution to the carbonyls, the majority is due to the thermal degradation of PG and VG, and we've got an example here on the left-hand side. So there's a few carbonyls there that have been measured, and just I think the context is really important here. So Ian's mentioned formaldehyde a few times. That is the bar that is the largest bar that's shown in that study. But for the context, and you might not be able to see it very well, that is 7 micrograms per puff as measured in that study. Now, as humans, we produce over 40 grams of formaldehyde in our bodies every single day just through biological processes. So whilst it can initially sound quite frightening that the devices are exposing us to formaldehyde, we are very well equipped to deal with it. And I think it could be argued that that level of formaldehyde against the background of what we already experience is really negligible. So one variable that can have quite a large effect on the carbonyls of vape aerosols is the coil temperature. So the study on the right-hand side there shows that when the coil temperature remains below 300 degrees, and that would be the temperature that would be associated with consumer use, carbonyls were consistently low. But above 300 to 350 degrees, you start to see that kind of exponential increase. It is a logarithmic scale used in that figure. You do see this quite substantial departure with the carbonyls. And there could be a few reasons for this. So it could be related to a dry puff condition where there's insufficient e-liquid in contact with the coil. It could be inappropriate puffing protocols used in laboratory measurements. But the key thing here is that vapors can detect those carbonyls. So if they have been puffing heavily, if there's a device malfunction, they can detect those levels. They would stop using it. It does not taste nice. So those high levels are not representative of human exposure. So the key message from this slide, without staying on it for too long, is that there's a lot of variability. So we see a little bit of variability from flavours. There's some from the vehicle constituents as well. There are other variables specifically relating to device. But when we layer that over the further variables of differences in aerosol generation and measurements, you really do get an evidence base that is difficult to compare. However, despite all of that variability, primary studies and high-quality systematic reviews report a substantial reduction in vape carbonyls compared to cigarette smoke, as shown in the table there. Finally, we'll talk about metals. So metals may leach from the coil and components of the atomizer into the e-liquid and transfer into the aerosol. Now, the figure from this study shows that there are quite big variations, again, within the same device types, but also between different generations. And I think it is correct and a valid concern of the authors to raise concerns around manufacturing quality standards. Generally speaking, the toxicological risk assessments that have been published on metals report that the metals in aerosol are generally below the health-based values. So it's usually the sub-ohm, quite powerful third-generation devices that are more likely to exceed. So we've talked a little bit about the carbonyls, we've talked about the metals, and whilst it is important to look at individual constituents and their exposure, it's really important to look at the kind of the context of the whole risk profile. So we've got a study here which has compared the cancer potencies of emissions from a range of different nicotine products with tobacco smoke, and has reported that the aerosols form a spectrum of cancer potencies spanning 5 orders of magnitude, which is a large difference, from uncontaminated air all the way through to tobacco smoke. E-cigarette emissions span most of this range, but the vast majority of products have potencies which are less than 1% of tobacco smoke. And I think it's important to reflect also that for dual users who are vapers and also use combustible cigarettes, they have lower biomarkers of exposure, which are lower metabolites of carcinogens, compared to those who continue to smoke. And the magnitude of the reduction is proportional to the degree of cigarette reduction that's achieved by vaping. So just to wrap up this myth, do vape aerosols contain toxic chemicals and metals? Well, yes, they do, but the presence does not infer consumer risk because the toxicological relevance is calculated based on dose and based on consumer exposure. So vapes are not risk-free, and we don't say that they are, but they do contain significantly fewer and lower levels of toxicants than cigarette smoke, and that's under robust and standardised testing conditions. Metals may be present, but they're often within regulatory safety limits. And I think this is a really important point because product quality and standards matter. And products from responsible manufacturers will undergo stringent testing and quality controls to minimise that exposure to any contaminants. And overall, the scientific evidence supports harm reduction for smokers, which is recognised by independent systematic reviews, for example, the Cochrane, which Ian mentioned earlier. So we've got my references here. There's quite a few, but as Ian said, they'll be available to download after the conference. And then moving on to my next myth, this one's a little bit shorter, also toxicologically focused. Flavoured products are more toxic than unflavoured ones. So the toxicity of flavour compounds is frequently cited as part of the rationale for flavour bans. Now, whilst that usually focuses on youth uptake, toxicity of flavours is usually worked into the rationale somewhere. And this particular myth is upheld by agencies like the World Health Organization. So I think the statements that are used to support the various quotes from the WHO, usually from studies which have been over-extrapolated or from studies which do not fully account for consumer use. So we'll have a look at the levels. So generally speaking, they're very low levels of chemicals in both flavoured and unflavoured vapes in comparison to the 7,000 chemicals which are in cigarette smoke. There is a slight difference, and the range is shown on the slide. But again, as we've said already, the presence of additional chemicals does not necessarily infer a risk to the consumer because the relevance from a toxicological perspective is calculated based on the dose and exposure. And we'll have a look now at some of the reported differences that have been attributed to flavours. And this is why it's really important that we don't take reported findings at face value. So one paper claimed that thermal decomposition of flavouring compounds dominates the formation of aldehydes during vaping, producing levels that exceed occupational safety standards, and that the production of aldehydes was found to be exponentially dependent on the concentration of flavouring compounds, which is really, really strong language considering they make up such a minor proportion of the overall e-liquid. Now, a replication study was conducted by Konstantinos' group, and the replication study found that actually the aldehyde emissions were substantially lower compared to what was previously reported, and that actually there were only minimal differences observed between flavoured and unflavoured e-liquids, which really highlights the importance of validated methods being used when analysing e-cigarette emissions. We'll have a look now at the flavour health effects, or the claimed health effects. So the evidence exists, but how reliable is it? So we've got a representative conclusion shown on the slide here. And I think the first half of it is probably what you're used to seeing. E-cigarette exposure might trigger an inflammatory response in a particular cell type mediated by reactive oxygen species. But this paper then goes quite a lot further and makes a jump that what is reported in an in vitro study actually provides insights into pulmonary toxicity and tissue damage in e-cigarette users, which is quite a big leap. So there was a commentary review which was done on that particular study, and the limitations which it highlights I think are really helpful to keep in mind when reviewing the wider evidence base relating to flavours generally. So there was a 2020 systematic review on the pulmonary effects of e-liquids specifically, and I think that first statement is still true today, and that's been echoed by other clinicians and scientists at this conference. There is little to no direct evidence of the toxicological effects of e-cigarette flavours in humans. The study did review what is predominantly an in vitro evidence base with a few in vivo studies, and have pulled out that there are a few usual suspects that are more likely to flag toxicological concerns, and they've highlighted cinnamon, strawberry, menthol, and a few other flavours. But generally speaking, there is a lack of consistency across the existing evidence, inappropriate controls, or just that controls are completely lacking, ambiguity over what would be a physiologically relevant dose and comparable to a consumer scenario, but also lack of assessment to establish dose-dependent relationships. So if a particular adverse effect is attributed to a certain chemical, you would expect to see a kind of a worsening or a more increased effect as exposure increases. So I think this is almost the final slide. So just wanted to say that whilst some particular flavour profiles have been called out, there are huge numbers of e-liquids on the market, and there is compositional variation between each of them. So there's probably hundreds, if not thousands, of watermelon flavours or strawberry flavours. So it's not necessarily that all of those profiles will be problematic. It will be the one, potentially, if it's been tested robustly, that there may be issues associated with particular levels. Now, robust studies from manufacturers and some other groups as well have reported that flavoured e-liquids did not increase the risk profile of well-stewarded e-cigarettes. And one of the systematic reviews has called out that actually there probably should be concentration limits set to reduce the potential for causing harm in humans. And I think that's, I completely agree with that statement, because that is the approach that responsible manufacturers are taking to set limits on individual flavour constituents. And whilst this presentation is focused on the tox aspect, it's really important to look at flavours in the broader context of tobacco harm reduction. So in the interest of time, I think I might skip the key messages, but you can download these after the conference if you would like to. And I will hand over to Konstantinos.
So, hello everyone. Thank you very much for the invitation and for Ian organizing such an important and interesting event. So, of course, as you understand, I cannot cover the whole area of lung disease and heart disease in that limited time. I will only discuss about a couple of cases. Now, the problem of medical and public health misinformation is basically either preventing smokers from trying to make a switch to harm reduction products, or creating a relapse to those successful former smokers who have quit using such products. And I've experienced such concerns daily because now I also have a social media channel in Greek, unfortunately. And I see the concerns of vapers, former smoking vapers, who always feel the pressure of several stories coming out, being in most cases misinterpreted, and creating this kind of confusion whether the decision was right or not. Unfortunately, in the cases where this misinformation is successful, people do not quit all products. They go back to smoking. And there are documented comments in my social media channels saying exactly that they felt something or they heard something and they went back to smoking. Now, the myths associated with the use of these products and of nicotine, basically, everything starts from the fact that these products contain nicotine. That's the big sin of these products, is that we assume that dependence necessarily means harm, which is not really the case. You may be dependent on coffee, but there is no harm associated with coffee. That's why the WHO does not discuss on a daily basis about the addiction to caffeine. There are several misperceptions, not only among non-experts, but also within the public health and the medical community concerning the carcinogenic and cardiovascular effects of nicotine itself, besides combustion or thermal degradation products. And many people think that nicotine is one of the most, if not the most, dangerous component of smoking. And I'm going to show you a study showing that. So a study that I published in 2016, examining the perceptions of Greek healthcare professionals. We found that over 75% of them believe that nicotine is an important or extremely important contributor to smoking-related lung cancer, while nicotine is not even classified as a carcinogen. The same percentage, a bit more, thought that nicotine has a very important contribution on smoking-related cardiovascular disease and cancer, not only of the lungs, but also in other organs. A study among Swedish and UK general practitioners found something similar, that nicotine was considered in both countries the third most important health risk-associated component of tobacco cigarettes, less important than tar and carbon monoxide, but more important than smoke and cured tobacco, which we know is not the case. And more recently, in 2021, a study among 1,000 physicians, members of the American Medical Association, 80% of them strongly agreed with the statement that nicotine causes cancer, and 83% strongly agreed with the statement that nicotine causes cardiovascular disease. So imagine if if these are the perceptions among experts who are supposed to know the literature, and the literature concerning, for example, nicotine and cancer is nothing new, basically. Imagine what's happening among non-expert smokers or former smokers who are using these products. And that's a problem. You know, concerning the cardiovascular impact, everything starts from the fact that nicotine has some acute effects on the heart rate and the blood pressure. We know that when a person smokes, or when they use also other nicotine-containing products, for the next 10 or 15 minutes, they will have slightly higher heart rate and blood pressure. This is a transient effect. It lasts for a short period of time, and I will remind you that exercise, which is a protective factor for cardiovascular disease, causes extreme elevations in blood pressure and heart rate. You can get up to 200 milligrams of mercury systolic blood pressure. You can get up to 150, 180 BPMs, but it's not a risk factor. You know, the transient change does not necessarily mean a risk factor. In fact, smoking is not even a risk factor for the development of hypertension. Of course, it adds to the risk of cardiovascular disease if someone smokes and has hypertension, but it's not smoking that causes the hypertension itself. So these are the myths, and the vast majority of the evidence concerning the health effects of nicotine per se is coming from snus. and snus is not just a nicotine product. It's a tobacco product containing nicotine, but it's a product that does not involve combustion, and a product for which we have such extensive long-term epidemiological evidence from decades of use, mainly in Scandinavia. So we have cured tobacco, we have nicotine, the same amount of nicotine intake for snus users as for smokers, but we don't have the combustion. And what does the epidemiology from snus use is telling us? There are several studies. None of them have been funded by the industry. Most of them have been performed by Karolinska University without any external funding. Concerning myocardial infarction, concerning stroke, they are finding that the risk of developing an acute myocardial infarction or the risk of developing a stroke, whether it's hemorrhagic, thromboembolic, or even unspecified, is similar between snus users and never users of any nicotine product. So it's not a comparison between snus users and smokers, it's a comparison between snus users and nicotine non-users. So, in some cases, there are impressive, literally impressive statements in the abstract conclusions, like in both these studies, the conclusions were that it seems that nicotine is not a main contributor on smoking-related cardiovascular disease. And this is mentioned by the scientists in the abstract conclusions. You don't even need to read the whole document. And these are massive studies, pooled analysis of several cohort studies. In the case of stroke, there were 130,000 participants, and that's very strong clinical epidemiological evidence. So I remember a few years back, I was invited by the American Heart Association to their scientific sessions. They had a session about e-cigarettes, and during the session, some scientists presented data that nicotine causes atherosclerosis of the descending aorta of mice. So before my presentation, I was in the audience, so I asked, and that was not the first study on mice showing that nicotine causes atherosclerosis. But my question was, why don't we see the data available from animal or cell studies being translated into human effects simply by looking at the epidemiology of snus? And the response was, we don't know. And my next question was that, should we trust the animal and cell studies or the long-term clinical human epidemiological studies? And there was no response at all, which I think is good enough of a reason to explain. Basically, I don't even understand why there are still organizations funding research on the effects of nicotine. I mean, in vitro, animal cell studies. I don't really understand that. We are at the point of having such strong epidemiological clinical evidence that there is no point in sacrificing mice for this purpose. The other issue that I'm going to talk about, it's not the only, I mean, I could speak about popcorn lung disease, which is a whole scare story coming from a study that I published in 2014, because I was the first to look at the presence of diacetylene in liquids and raising this issue, an issue that does not exist. But even today, everyone is talking about popcorn lung disease. Last year, I was testifying in the Parliament of South Africa, in the Parliamentary Committee for the new tobacco directive that they are preparing. And some MEPs were asking me, what are we going to do with the kids that are being hospitalized from popcorn lung disease? And I said, where have you seen these cases? There are nowhere, they don't exist. Not only they don't exist in your country, they don't exist anywhere. It's just pure rumors and speculation. They don't exist. Anyway, I don't have the time to discuss about popcorn lung, but I'm going to discuss about another lung condition, the EVALI panic. And you can see, remember in 2019, early 2020, what happened with the EVALI epidemic in the US, which was an epidemic of acute, severe lung inflammation, but acute, and that's very important. It was determined that it was not due to long-term use of something. It was an acute lung injury happening within days up to 3 weeks after using specific products, which at that time they said it was e-cigarettes. And that is the result of that story in 2019 of videos in social media.
This is what vaping can do to your lungs. The top image is a CT scan of the chest of a healthy individual, but the bottom scan is a 19-year-old that was diagnosed with e-cigarette vaping-associated lung injury. This condition is known as EVALI for short, and it has been diagnosed in several individuals. In the individual that's vaping, you can tell that there's something called ground glass opacities within the chest. This can be an indication that there's a severe inflammatory reaction happening within the lungs. Individuals who vape are exposing themselves on a regular basis to chemicals that can potentially dissolve within their body and cause injury to their lungs and other organ systems.
I am on a personal crusade with the vaping because I have had some very personal experiences with young people in particular that have had some devastating consequences as a result of vaping one time. Let me qualify this by saying it's new. And we really don't know what the long-term implications are of vaping. I have seen young individuals vape one time and end up in absolute lung failure to the point that we have to put them on an external lung machine called ECMO through the blood vessels until their lungs actually heal.
So, literally, this is 2025, the latest one. The previous one was 2024. The outbreak ended in early 2020, yeah? The CDC even stopped recording any cases in early 2020. I will show you. First of all, let's see why it was impossible for this to happen due to e-cigarettes. E-cigarettes had been available up to 2019 for 10 years, all over the world. We're talking about tens of millions of consumers. There had never been any epidemic anywhere in the world of any acute injury. Yeah? So suddenly, only in the US and only in specific age groups, those were either adolescents or young adults, we saw a large number of cases of this acute lung injury that didn't exist in any other country, didn't exist 1 year before. It started during spring of 2019, and it escalated during autumn, September, October. So why did that happen in 2019 and not all these previous years that the cigarettes became available? From a common sense and from an epidemiological perspective, it is pretty clear that either something new circulated into the market in the US and was particularly popular among this specific age group, because you didn't have 40-year-olds having this condition, or it was something else that again was new in the market and didn't exist 1 year or 2 years ago. So that's without even knowing what these people were using. However, the CDC called it EVALI, which is an acronym for e-cigarette or vaping-associated lung injury. Why they named it using the term e-cigarettes, at the same time, they started, and very early, to warn about THC products and not e-cigarettes. So this is a warning from the CDC, who named the condition using e-cigarettes, and they are saying that they are talking about tetrahydrocannabinol and cannabinoid compounds associated with this disease. The FDA was much clearer. They released a statement in early September saying that avoid using THC-containing vaping products, and that's a problem with terminology also, because you know that smoking cannabis is not considered smoking. We don't call these people smokers. In the same way, using such devices to aerosolize and inhale cannabis should not be called vaping. Vaping and e-cigarettes are mainly nicotine-containing products. So the FDA was very clear, you should stop using these products, particularly when you buy them from illicit sources, obtained off the street. So at the very beginning, and this is 2019, I remind you that the previous videos on social media was 2024 and 2025, but since then we knew what was probably the case, and By February 2020, first of all, the CDC said that we stop recording cases. There were no new cases. And they identified vitamin E acetate as a culprit, as a reason for this condition. And it was, in fact, not even legal appropriate THC products. They were products that were adulterated with vitamin E acetate because vitamin E acetate was cheaper than THC oils. And because of having the same consistency, the same appearance, the same viscosity, it looked like a legitimate THC product. So some clever guys thought that it's a good idea to get some money by putting something which is much cheaper, so basically adulterating the product and pretending to be a pure THC product. That's what happened. And you know, in late 2019, early 2020, some arrests took place in the US of people who were marketing these products in the illicit market, and that's it. There were no other, there may be some sporadic cases around the world, but there was no other epidemic. So that ended in 2020. Last year, an official scientist from the Greek Society of Respiratory Physicians was in the Greek parliament testifying for a new law for tobacco and nicotine products, and she was saying that young people die in the US because of a valley due to vitamin E acetate in e-cigarettes. That's exactly what she said. There are physicians who have social media channels a few months ago, and they were talking about a valley being a condition solely associated with e-cigarette use. No discussion about THC at all. And, but even when you look at evidence from the US, this is a study that was published by scientists from the New York State Department of Public Health. It was published in a special issue that I was one of the guest editors in Toxics, and they took all the products from victims of a valley, and they measured, and they checked them with GCMS and other analytical methods to see what they contained. And they were both nicotine and THC products because, you know, as in the same way that usually cannabis users are also smoking tobacco cigarettes, cannabis vapors are also using electronic cigarettes in many cases. So they tested everything for vitamin E acetate, and they found that 64% of the recovered illicit cannabinoid products contain vitamin E acetate at levels up to 55%, yeah? While none of the nicotine products contain vitamin E acetate. Why they didn't contain vitamin E acetate, the nicotine products? There are two reasons for that. One reason is because you must be very stupid to use vitamin E acetate to adulterate e-liquids because it's more expensive than any other of the ingredient of e-liquids. So the reason they were used in cannabis products is because cannabis oils were more expensive than vitamin E acetate. In the case of e-cigarettes, flavorings, PG, VG, and nicotine are cheaper than vitamin E acetate. So there is no reason to adulterate it with vitamin E acetate. The other reason that this will not happen with e-cigarettes is because it's impossible to dilute vitamin E acetate in nicotine liquids. And I don't want to be theoretical on that. I'm going to show you what I did at home. So I bought vitamin E acetate and an e-liquid, and I tried to mix them in the same bottle. As you can see, it's speeded up. I genuinely tried to mix them. I mean, I very vigorously shaked the final solution in order to try to mix the two ingredients. You see, of course, vitamin E acetate is very thick, and that is consistent with the viscosity of the cannabis liquids, not of nicotine liquids. But besides that, I even tried with my hand much more vigorously to dilute everything. I can't show you all the video because it's 15, 20 minutes. But I did, you know, I did everything I could. As you can see, once you leave it, and after some times, usually after 15, 20 minutes, it gets completely separated. You will see here how they start to separate. And this is the end result. Now, look how well the middle bottle does not contain any vitamin E acetate, but look how they are completely separated. It's exactly the case of mixing vegetable oil with water. This is what happens. So if someone even wants to produce something like that, even before sending it to a retail store, it will be completely separated. Everyone is going to see that, even if you do it by mistake. It cannot happen. So there is no way that this can happen with e-cigarettes. I had to release this video in my social media channels because, you know, just saying that it can't happen is not very convincing. So what's happening with the flawed science that is being used in order to create all these myths and create this havoc among smokers and, unfortunately, even former smokers using these products? We have cell and animal studies which basically overexpose to levels which are extreme. I mean, they're trying to simulate in mice nicotine levels present in humans while mice metabolize nicotine at twice or 3 times the rate of humans, and or giving doses which correspond to a 70 kilogram human, while the mice are 60 grams. You know, on a per weight basis, the level of exposure is tremendous. There are bad chemical studies like the one you showed, and it's interesting to tell you that when we try to replicate the study that you mentioned on flavorings dominating aldehyde emissions, I contacted the author. And I asked him to tell me what kind of liquids he bought, because the devices were already visible by name, but he didn't report the names accurately. And he denied responding to me. He basically attacked me for trying to replicate his study. You know, I was very polite. Unfortunately for him, one of the products has the characteristic name, and basically, I wouldn't be able to find it, but some vapors from the US contacted me and told me what the brand is, because it's the only brand that has this specific name in one of their watermelon, I think, product. And that's how I found out what kind of brand he used, and because in some cases there were also sweetened versions, I made sure to buy normal and sweetened versions to make sure that, but the differences were 3 orders of magnitude. 2 to 3 orders of magnitude. It's tremendous. You know, we're not talking about a 10, 20% difference, which can happen, you know, between laboratories. We're talking about 500 times lower levels, 1,000 times lower levels, using the exact same equipment, exact same liquid, exact same puffing regime, everything identical, in a certified lab for chemical analysis of e-cigarettes in the US. So, and of course, after that, you have the media manipulation. I mean, I've even seen cases of a young girl, a teenager with popcorn lung disease. The story had appeared in mainstream media like People's Magazine. And because there was a photo and the name of the patient, I managed to find a very healthy teenager on social media posting stories next to swimming pools and with fancy clothes every day, with this irreversible lung condition, as they were saying in the article. And when I contacted her, and I verified it was her, not only by name, but also with her face on the videos, she said that it's not me, please don't send messages to me about it. I mean, if someone told me that my face and name is being used in an article that has nothing to do with me, but they use my face and my name, I would be furious to those, you know, writing the story. Not furious against the person who told me about it. I'm going to leave that to you to think about what's going on with these stories, but these stories don't make any sense. So, unfortunately, all this is a public health failure and is indirectly and unintentionally, obviously, protecting tobacco cigarette sales. Because these inaccuracies, the media amplification of the stories, creates distrust, mistrust on the product, misperceptions on these products. Smokers are not willing to try them. Vapers may even relapse back to smoking. And that's a huge ethical problem that we need to take care of. Thank you very much.
Thank you all three presenters for the really insightful presentations. I do realize we're right up against lunch. We did start a little bit late, so if people are okay with that, I know Roberto's got his hand up and some others may have quick questions or comments. So if we can make them quick, and we'll try and fire off responses. So go ahead, Roberto.
Yeah, would like to dispel a myth that high-power devices are inherently toxic. This is because when they test them, and we have published already 5 reviews covering 100 studies, and when they test the high-power devices, they use a very insufficient airflow, and we have replicated them. So this is important. Most of the high contents of metals and aldehydes come from testing high-power devices, but they are not well tested. Once you have the correct airflow, and we have a laboratory test on that, then the amount of toxins in the aerosol is comparable to low-power devices. I wanted to say that, and that's all. It's an important issue to say.
I think that's hugely important, Roberto, and the work that you do in critiquing other people's work, the work that Konstantinos talked about, the replication products, and also Ricardo Pelosa as well is doing a lot of replication studies. It's hugely powerful and really important to this arena, so I appreciate that comment. Any other questions or thoughts from the audience? Sorry, lady at the back, there, in the middle. The microphone's on its way.
Hi, I'm Cecilia from Sweden. I think I would like your comments on the statement, nicotine negatively affects the adolescent brain.
Negatively affects
The
adolescent brain. Which one of you would like to address that? I think Ariel seems keen.
Lynn Dawkins is not here, but I know she's looked into that recently. As far as I understand, it's based entirely on mouse and rat studies.
I imagine that during the 60s we would either have a society full of mentally retarded people, or we would be all Einsteins today that the smoking rates in adolescents have gone down. None of this has happened. So I think that when you look at on a large population scale, I doubt there is any measurable effect on brain and neurological development from using nicotine at a slow age, or having kids being exposed to second-hand exposure to nicotine. Otherwise, I'm telling you, in the 50s and the 60s, we had, 40% of the kids vaping, 50% of the population, which means that the kids were exposed at home to nicotine all the time. We didn't see any mental retardation that would be measurable, an epidemic like that was resolved in the 80s, 90s, 2000s. Nothing has happened like that. So I doubt there is any clinically meaningful effect. It hasn't been proven clinically, yeah? But yeah, in mice, as I said, you can expose mice, they weigh 50 grams, 40 grams, 60 grams. I mean, the amount of exposure, whether it's aerosol or nicotine that they provide to these animals is tremendous for their weight, So how can you translate these effects into human clinical effects? It's very hard. I think the big value of in vitro studies is only in making comparisons and comparing the relative effects of one product versus the other. Now, what's going to happen in humans is a completely different story. But at least you can have a comparison. When you compare it to clean air, in a cell culture, if you add enough water into the culture, due to the dilution effect, you will have adverse effects on the animal, on the cells, because you're just diluting the nutrients. You may change the viscosity. You may change the pH level of the culture, and you may have effects which have nothing to do with what you are adding. You're just adding too much. So the big value in these kind of studies, I think, is when you compare a known exposure with something else. Identifying the absolute level of risk, I think it's impossible.
Thank you. Appreciate those two comments. And any other quick from the audience before we head out for lunch? you have something else, Roberto?
Yeah, I just want to say that among these 100 studies, 40 were preclinical. What we found is very interesting because people who do preclinical studies are normally biologists and toxicologists, and they know their trade very well. It is virtuous the way they describe the biological processes, but they are absolutely ignorant on how to generate the aerosol. And this is critical, this is important. If you are going to expose mice or cells to an aerosol, you better be certain that you are using the right aerosol. And we discovered 40 studies that literally poison these biological systems. They expose them to an aerosol that would be toxic for a human. Now imagine for a 25 gram mice. And this is important also because a lot of the scare about the perception that vaping is dangerous is coming from preclinical studies. Preclinical studies are very hard to understand. It is complex, and also they use language like DNA and mutagenesis and so on that looks very, very horrible. Yeah. But these are the sources of a lot of perception that vaping is harmful. And I think we just discovered a tiny tip because we identified 67 more studies that were certain that expose mice to overheated aerosols.
Well, just one sentence. I remember several years back, I sent an email to the main author of an in vitro study, asking him why did he use that amount or that concentration of nicotine to expose the cells to. And his response was, in order to generate an effect. So he wanted to create a problem. So basically in these studies, you can just order what kind of effects you want to have, and they can adjust the methodology and the amount of exposure and get to the result that you want eventually. But how meaningful is it on for clinical effects on humans? That's what we're discussing.
And I think as well, I think historically, Ricardo, from my own perspective anyway, these sorts of animal studies, massive overexposure studies, were done to look at the impacts of cigarette smoke, and they were accepted because it was a slightly more noble cause. And I think that needs a mindset change where people absolutely, like you say, do have to understand that there's a potential health impact of that misinformation, and you need to understand what the user is doing, replicate that in the laboratory to fully understand what might happen to them when they switch from smoking to vaping. I'm conscious as we've just really hear people's bellies rumbling from here. So I just once again like to thank Ariel, Libby, and Konstantinos. Really appreciate your attendance. Hope you've learned something. Please do feel free to grab us after the session or at any point if there's anything else you want to ask, and enjoy the rest of the conference. Thank you.